So today I'm going to be discussing about integration methods, mainly in simplification, and there are four ways you can do this, either logarithmic integrals, or partial fractions, or by integration by parts, or division or insertion. So for this example, we have the integral of 4dz over 2z plus 3. So first we have to identify which one we are going to use, which method we will use to integrate it. So in simplifying, you have four ways, right? Integration by parts. So integration by parts, you can only use integration by parts if it's a product. So if it's like e x x, you can use integration by parts because it's a product, and the resulting x, when you substitute it with dx, du is equal to dx, is dx. And you'll know what I'm talking about when I'm gonna explain that later on. And the next one is partial fractions. You can use partial fractions if the denominator is factorable. Here, the denominator is not factorable. Although you can separate them, it's not factorable by a common multiplier or factor. And division or insertion, well, you can do division or insertion here, but that will be complicated and it might not be the right answer. So what you can do actually is use substitution, either substitution by trigonometric or algebraic. Trigonometric is more complicated and it has specific formulas. However, we will use algebraic for this because we can actually substitute the denominator here. Let's set u is equal to 2z plus 3. So the denominator will be our u. And then we can get the derivative of u, which is 2dz. Then we can divide the whole thing by 2, so we can isolate dz, and you will be left with du over 2 equals dz. And you can substitute in dz on top here, and this will be 4 du over 2 over u, because we set our 2z plus 3 to u now, so we don't really have to write everything down. We can just substitute u, and it's more simpler to do. And then all we have to do is divide 4 and 2, because this is in the new top portion and this is the denominator as well. Or you can simplify that, or you can bring 4 and 2 on the left side of the integral because it's a constant, but you know that's gonna be 2 either way, so we'll just do this as a step-by-step process. Then you can bring du here and over u. Now remember the logarithmic formula? Du over u is equal to ln u plus c. So we can use that to integrate this. So the answer is going to be 2 ln 2z plus 3, because that is our u plus c, and that is the answer. So for the number 2, it's the same thing as the one on the left, the first example. All we have to do is you do the same process. So we let u is equal to 4x minus 2, and 4x minus 2, we get the derivative 4 dx, and then divide it by 4. So we can get our dx is equal to du over 4. So here, dx is on the right side. We can just substitute that, or we can bring dx on top here to make it the same as the first example. So we know that 6 dx is going to be du over 4 over u. Then we can bring 6 and 4 on the left side because it's a constant. 6 over 4 du over u, and again a familiar pattern arrives, and du over u is the same as ln u plus c. So we can simplify 6 and 4. It's going to be 3 halves, and then ln absolute value u, which is your 4x minus 2, plus c. So for this example, we have a factorable denominator. Like I said, you can use partial fractions when you have a denominator that is factorable. In this case, this is a quadratic. So let me simplify it to x plus blank times x plus blank. So as you can see, we can factor this out with 3 and 2 because 3 and 2 is a product of 6 and it is also a sum of 5. So in doing partial fractions, x minus 1 over x plus 3 times x plus 2, we can decompose them into a over the denominator x plus 3, first denominator, plus b over the second denominator, which is x plus 2, second factor. If ever you have more than two factors at the denominator, then you can add c over the third one, or d plus d over the fourth one. But in this case, this is a binomial, so we use this. If ever it's a quadratic, which might get complicated, then there might be a chance that your b is going to be something like bx plus c. If the second factor is like it has a square, where it's squared. So in this case, it's simple because I only gave an example that is two binomials. So now we just multiply this by x plus 3 times x plus 2. So we can cancel these out into x minus 1 equals a, and then cross multiply x plus 2 plus b times x plus 3. Alright, so in doing partial fractions, we have to identify the numerators a and b. And to do that, we have to set the opposite or the other letter into a 0. So to find that, we have to solve for a. We're going to have to let the x of b equal to 0. So here we can just write x as negative 3 because negative 3 plus 3 is 0. And then we have x is equal to negative 3. Substitute negative 3 into this equation. Negative 3 minus 1 equals a times negative 3 plus 2 plus 0 because b is now 0 when you multiply it by itself. And then this is going to be negative 4 equals a times negative 1. And then you can just multiply the whole thing by negative 1 or divide both sides by negative 1. You will still get a is equal to 4. So that is for our first letter. Then let us solve for b. For b, we will set a as the x of a to 0. So ax plus 2, then we get x plus 2 equals 0, which is x is equal to negative 2. Just transfer 2 to the right side. And then we can set all the x's here to negative 2. So it will be negative 2 minus 1 is equal to 0 plus b times negative 2 plus 3. And this is going to be negative 3 equals b times 1, which b is just negative 3. So now that we have negative 3 and 4, we can use this now. We can use this equation as the one we are going to integrate. So integral of a x plus 3 plus b x plus 2 dx. Don't forget about dx. So our a is 4, so we can substitute 4 on a, and b negative 3 x plus 2 dx. And then we can distribute dx, so we can integrate each term on its own. So integral of 4 dx over x plus 3 plus integral of negative 3 dx over x plus 2. And then here 4 and negative 3 are both constants, so we can separate that on the left side, plus negative 3 dx over x plus 2. And then this is another familiar formula. Essentially, it's the same as du over u. So we can just let u equals x plus 3 and u sub 2 is equal to x plus 2. I'm just replacing the denominator as u. And then we can do the formula now. For ln absolute value x plus 3 plus or negative 3 minus 3 minus 3 ln x plus 2 plus c. So that is the answer for this problem. So the next problem is integral of x squared times ex. So I explained this in the first part, where as long as these two are products, then we can use integration by parts. Now integration of parts uses a formula, which is integral of u dv is equal to uv minus v du. And for this case, we can actually use that for this. So what I'm saying that we can use the we can integrate it by parts, because if we let ex as our u, like we are using u substitution, then if we get the derivative of ex, then it is going to be ex dx. And when we substitute that in this equation, then we are going to be left with x squared du. And we can't do anything about this. We can't really simplify. So that's why the integration by parts comes to rescue us. So we can let u equals x squared instead for this, and then v is equal to, or the integral of v du. You can actually let that du equals integral of ex dx, or you can just cancel these two out and you can be left with ex, basically the v. And then getting the derivative of v, I don't think that's needed, but getting the derivative of u, then that's going to be dx, 2x dx. So now we just substitute that into this formula, and uv it will be x squared, and then v is going to be ex minus integral of v du, and v is our ex, and then du is 2x dx. And notice how we can have the left side is already integrated, however the right side here is not yet finished. It's the same as chain rule. So notice that this is now simplified into this. So all we have to do is do the chain rule or the integration by parts again. So we can let u is equal to 2x instead, and then du is going to be 2 dx. Okay, and then v, let v is equal to ex integral, because this has an exponent of x. Alright, so now we can do the integration by parts again. So I'll just write this here, is equal to u is your 2x, and then 2x ex minus integral of ex2x, and then your ex2x is v ex, and then derivative of u 2 dx. So now this is integral. There's a formula for this. The integral of ex dx is just ex plus c. So we can, since 2 is a constant, we can just put it aside on the left side. So that is going to be 2x ex minus 2 integral of ex dx. So here we have now simplified it into this. Now we should also attach this into here, because minus this is the same as this. So I'm gonna write the full equation. So x squared ex minus 2x ex minus 2 integral of ex dx. So all we have to do is do the operator on this one. So you can just write it as x squared ex minus 2x ex minus 2 ex plus c, and that is your answer. Okay, so before attaching x squared ex here onto this one, you should also take note that this is a negative symbol. There's a negative symbol here. Therefore, there should also be a negative symbol here. And since this is a negative symbol, then if you distribute the imaginary 1 onto this whole thing, then this should be a plus. So therefore, this is actually your final answer. Do not forget about this sign. So for the next one is this. So there is a bit of a problem here. You can't use partial fractions because this is not factorable. You can't use integration by parts because it's not a product. You can't use u substitution, because if you use u substitution, let u is equal to x minus 2 and du is equal to, then that's going to be dx. And you can't really do that, because if you just let dx here to your du, then that won't work. And you can also use integration by parts, because yes, it's just not a product. So what we are going to use is division or insertion. So there's two ways to do division or insertion. Well, for division you can do long division or synthetic division. But for insertion, you can do plus 2 minus 2, and then you can get the square of this, which is going to be like the square root 2. But that is more confusing than what is necessary. So a method to do this is division. So for the division, we can use synthetic division, and we can set x as our 2. This is going to be our divisor, and then we can use the method of synthetic dividing, and we 2 times 2, 4, and 4. So this is how you do synthetic division. Basically, you bring down 1 here because this is x squared. So you can imagine that this is x squared and then x and then plus a constant. And then first, for the first term, we will also always bring it down, and then we multiply it with the divisor, and then bring it here, and then add 0 and 2 to get still the same, to multiply it with the divisor, and so on, until you get to the end. Now since we are dividing, then this first term is going to be our x, and this is going to be our constant. However, this one is our quotient. So when you write a quotient, you will also always write the number over the denominator, which is x minus 2. So we can rewrite this as x plus 2 plus 4 over x minus 2. So this is now our dx symbol. So now we can just distribute dx and integrate it part by part. So that is fairly simple because this is just addition. So the integral of x dx plus the integral of 2 dx plus the integral of 4 dx over x minus 2. We can write this as x squared over 2 plus 2x plus 4 and then ln x minus 2 plus c. And that is actually your final answer, and that is it.